Welcome to MOG Economics. Today we're going to continue our Econometrics class on multiple linear regression. So we shall be looking at multiple linear regression. So this class is a continuation of what we had the other time. We are going to be looking at the estimation of the variances, the standard deviation, or what we call the standard errors, and the goodness of fit. So we're going to be looking at the variances, standard errors, and the goodness of fit. Here we're going to be talking about the R squared and the adjusted R squared. So we start our discussion with variances and standard errors. So after obtaining the OLS estimators, we can also derive the variances and the standard errors. And from our basic knowledge of statistics, you know that your standard error, which is just like your standard deviation, is the square root of your variance. Is the square root of your variance. So in essence, what we are saying is, after to get your standard error, you have to get the variance first. So the standard error, which is also the standard deviation, is the square root of your variance. So after estimating your beta 1 and your beta 2, you can also derive or estimate the variance and the standard error. For instance, we are going to be working with a regression equation. Yes. All right. X2, X3. So what we're going to be working with here, we're going to be working with a regression equation that passes through the origin, meaning the intercept is 0. There's no intercept, so we're not going to be having beta 1 here. So in this case, we can calculate the standard error for beta 2 and also the standard error for beta 3. So the standard error for beta 2 would be equal to the variance, the square root of the variance for beta 2 while the standard error for beta 3 will be equal to the square root of the variance of beta 3 . But how do we derive the variances of beta 2 and beta 3? The variance of beta 2 is equal to, this is the variance of the residual term, or the variance of the error term, divided by the summation of x2 squared into 1 minus r squared So your R here is a correlation coefficient between the second variable and the third. In this case, we can say R23 squared is the same thing as R squared x2 x3. So how do we break this down? So as we move on, you see that we have a lot to break down. We're going to do that here. So this is the variance of the residual. So the variance of the residual here is equal to the summation of the residual over n minus k. Now the n minus k we have down here represents the degree of freedom. Where n is the number of observation, or what you call the population, and K is the number of parameters to be estimated. And when we say parameters to be estimated, we mean the beta terms. So in this case now, our K is equal to 2 because we have beta 2 and beta 3. They are just 2. While your N is the number of observation of the population depending on the data set you're given. So that is for beta 2. Then we can also do the same thing for beta 3. We have the variance of beta 3 will be equal to the variance of the residual over summation x3 squared into 1 minus the correlation coefficient, so 3. And don't forget I said the other time, in this case, x2, x3. So we have been able to prove how to derive the variance of the error term. Now, how do we derive this? How do we get this? So the go to summation x2, x3 all squared all over summation x2 squared summation x3 squared. You can put this in different brackets. So these are what we need to estimate. So after doing this now, you get a variance for beta 2. You take the square root, that becomes the standard error for beta 2. You get the variance for beta 3, take the square root, that becomes the standard error for beta 3. Now the important question is, why are we doing the standard error for beta 2 and beta 3? There are basically two reasons why we are doing that. The first reason why we are doing that is to establish or to establish the confidence interval. So when we talk about the confidence interval, we say, okay, at 95% confidence interval, 90% confidence interval. So we are saying, okay, I am confident at 95% or at 90% that this will happen. And this will come in when you are testing your hypothesis. So that is one. Then the second one is, that is also a corollary to this, to test statistical hypothesis. So these are the two reasons why we need our standard error. So our standard error is to establish confidence interval and also to test statistical hypothesis. So the two reasons why it is very necessary for us to conduct the standard error of the estimators. Now, after going through all this, now let's take a practical question. Let's solve a question on this to show us how to estimate this. We have seen the formulas to derive them. So the next thing is, okay, let's apply this to a question. So we are going to be working with the question on the board, and it is very important to state that this question is in deviation form already. So we don't need to go through the method like we did in the previous class. So this is already the deviation method, and we can proceed from here. And you can also see from the equation also, everything was written in small letters. So that's to show it's in deviation form already. So what do we need to do? We want to take the standard errors for beta 2 and beta 3. And from what we did earlier, for us to get the standard error for beta 2, we said standard error for beta 2 is equal to the variance, square root of the variance for beta 2 hat. And the standard error for beta 3 hat is equal to the square root of the variance for beta 3 hat. Now, how do we get the variance for beta 2? The variance for beta 2 hat is equal to, and that is the variance of the residual, all over summation x2 squared into 1 minus r23 squared. So what are the things we need here? We need to get this. That's summation u squared over n minus k. So from here, and don't forget I said n minus k is the degree of freedom. So what's another thing we need to get? We need to know what is the formula to calculate this, and I said that earlier. I said this equals to summation x2 x3 all squared over summation x2 squared summation x3 squared. So these are the things we have to work out. So we start this is at here. So we start by taking the summation the x squared, x2 squared, we get this down, x3 squared, we get this down, then x2 x3, we get this down. Then we are also going to be working out the u art, and after that we have the u art squared. So those are the things we need to get out. So from here now I'll just put this down. S2 squared, that is 1 1 4 9 9. I hope you know how we did that. 1 times 1 minus 1 squared minus 2 squared there. Then this will give us 400 squared should give us 160,000. 500 squared should give us 250,000. Then 300 squared should give us 90,000. This should give us 250,000. Should give us 250,000. Then x2 x3. x2 x3. We are going to be multiplying this. x2 is minus 400 minus 500 minus 600 minus 1,500, then minus times minus is plus, so that's 1,500. So what do we do next? Let's take the summation of this, but before that we need to get our u art. So u art now, for us to get our u art based on what I wrote here, it has to be y minus beta 2 art x2 minus beta 3 art x3. So that means we need to estimate what our beta 2 art is and what our beta 3 art is. But that's not the purpose of this class. We have done that in the previous class. I had estimated that for us. So I'll just be bringing the value here. The beta 2 I estimated is equal to minus 1.4713. Beta 3 I estimated is equal to 0.0398. So that's the value of beta 2 here and the value of beta 3 here. So what do we need to do? We need to get our u art. So our u art now, for the first one, I'll just be doing the first one, then I'll leave you to do the remaining one. So for u art, for the first one, we have it to be y minus beta 2 at x2 minus beta 3 at x3. This gives, what's the value of y here? Minus 15. Minus 15 minus, our beta 2 is minus 1.4713 multiplied by our x2. Our x2 is 1 minus 0.0398 multiplied by our x3 is minus 400. So when you do this on your calculator, you are going to arrive at 2.3913, and we also need the square of that, right? After doing this, 2.3913. So the square of that is 5.7183. So that is just for the first one. I've showed the working, so you can take your time to do that. So we have minus 1 for the second one. I got this. The third one I got this. Then the fourth one fifth one. So we have this 129.3065 26.1878 32.3317 and 20.3753. So that's everything we need there. So let's do something. Let's break it down. So what we need in all of this, for this now we need summation x2 x3 all squared, right? But let's do this first. Then we have x2 x3 all squared. We need summation x2 squared. We need summation x3 squared. These are the things we need for this. Then we need the summation of u r squared. We need n and we need k. So our summation of x2 and x3 is adding this side, minus 400, minus 500, minus this, then this. You see, obviously, this will offset this, that's 0. Then minus 600, minus 500, that's minus 1,100. Minus 400 is minus 1,500. So you take the square of that. That will give us 2,250. Then summation of x2 squared. Summation of x2 squared, that's 1 plus 1 plus 5, that's 6, plus 9, that's 15, plus another 9, that's 20, that's 24. So we are going to sum this up. That should give us 1. Then the summation of the u at that we have here, that should give 213.9196. Then our n, the number of observations, 1, 2, 3, 4, 5. Then the k, number of parameters to be estimated, that's 2. So from here we can move on. From here. So what we need to do now is to calculate the standard deviation, the standard error of beta 2 and beta 3. So permit me to rub this off. So I want to take for beta 2 this x2 squared 1 minus r. Right, so let's take this. So this gives 213.9196 over n minus k. What's our n? Our n is 5. So 5 minus 2. So we are left with 213.91 all over 3. That will give us 71.3065. So we calculate this also. 23 all squared. We are going to have summation x2 x3 all squared, summation x2 squared, summation x3 squared. So I will have to rub this off. We can have enough space to do that. So we have 2, 3 squared across. Summation of x2, so we have 2, 250, 1, 2, 3, all over x2, that's 24, 1, 2, 3, 1, 2, 3. So that will give us So we have 0.09375. So for variance now, we have variance of beta 2. That is, what's the value of that? That's 71.3065 all over summation of x2 squared. That's 24. Multiply by 1 minus 0.09375. If you do this on your calculator, you are going to arrive at 3.2785. So now what is the standard error of beta 2? Standard error of beta 2 is the square root of the variance of beta 2. So that will give us square root of 3.2785. That is 1.8107. That is the standard error of beta 2. Then we do the same thing. We do the same thing for beta 3. So the variance of beta 3. The variance of beta 3 is equal to summation of x3 squared. So this gives 71.3065 over this, that's 1 million into 1 minus, we have 0.09375. So if you do this on your calculator, you are going to arrive at 0.000078868. Now what is the standard error for beta 3? Standard error for beta 3 is the square root of variance of 3. So that will give us the square root of, what's the variance now? 0.07868. So we are going to have as the standard error 0.00887 as our standard error. So that's the end of our discussion on the variances and the standard error. And I mentioned earlier that there are basically two reasons why we are doing this. The standard error, we need to know the standard error to establish the confidence interval. Confidence interval. Well, suppose it's okay. What's the confidence interval that we're going to be working with? So you need to establish your standard error to know what the confidence interval will be, and also for the purpose of hypothesis test. And we're going to do that most likely in our next class, where we'll be talking about t-test and f test. So we move on to don't continue. We're going to be starting our discussion on the goodness of fit. Goodness of fit. The R squared and adjusted R squared. Now, what is the goodness of fit? After estimating
please like and subscribe.